Dear students, now let me solve the next question on friction. Okay, and here the question is, find the minimum horizontal force F. We have to find out this force F. Find the minimum horizontal force F required to keep the block stationary with respect to the wedge. So we have to find out the force. How much force is required to maintain this mass small m as stationary? Okay, stationary with respect to the wedge, of course, because if you give a force F, then capital M and small m both are moving, but we have to find out the minimum force such that this mass small m is at same position, will be at same position with respect to the wedge. That means these two blocks, capital M and small m, will be moving with same acceleration. It will have no acceleration, no movement along vertical direction. The only movement is along horizontal direction. So we have to give this force in such a way, in such an amount, you can say, such that this small m do not have any vertical acceleration, and the capital M and small m mass will be moving together. So what will be the acceleration in that case? Acceleration will be obviously F divided by capital M plus small m. There is nothing but the force divided by total mass. Now if we draw the free body diagram of small m, so what are the forces acting on small m? One force is mg along downward direction, and obviously due to this mg force, that the block wants to slide downwards. So the relative motion of the block with respect to wedge along downward direction. So between this surface, a frictional force, limiting frictional force Fl will act, and the block will be remain at its original position only when this Fl will balance this vertical force mg. That is, when Fl will be equal to mg. Only in that case, the block small m will be at rest with respect to, will be stationary with respect to the wedge. Okay. So the block is moving along forward direction. So obviously the acceleration will be along this direction. And what are the forces acting along the horizontal direction? Obviously this block capital M will give a force on small m. Let me take this as a n. So m will also react with the same force, that is n. So that is action reaction force. So obviously on the block small m there is a force along horizontal direction n, and due to this force the block will be moving along forward direction. And we have to put this force in such a way, we have to put this force F in such a way that this n is enough to take the object small m along forward direction, and in that situation of course this Fl will balance this mg. Okay, now what is the actual situation here? If we just mathematically, you have to find out the A first for small m, or the A is actually same for small m and capital M. So this is the common acceleration, F divided by m plus m. And now if we just use the equation of motion, that is summation Fx is equal to ma, then summation Fx is only one force n, so that will be ma. Okay, and another equation you need, summation Fy is equal to 0, because there is no acceleration along the vertical direction. There need actually no acceleration, and this Fy is nothing but Fl minus mg. So Fl will be equal to mg, and Fl is obviously mu into n, so mu n is equal to mg. Okay, Fl is equal to what? Mu n, and n is what? Ma. So from here you can say that mu ma is equal to mg. So A is equal to g by mu, and A is obviously what? F by m plus m. So F by m plus m is equal to g by mu. Okay, so what is the force? What is the force required? So F will be m plus m into g by mu. So this is the minimum force that is required, m plus m into g by mu. This is the required minimum force that is required to keep the block stationary on the surface. Okay.